Okay, this is week 12, timed relays. This is one of the more difficult units for people to get their minds around and understand how time relays are working. So you're gonna maybe have to watch this a couple times and really reinforce what you've learned in your reading. So there's a lecture worksheet that goes with this. You can watch this video. Obviously, you're watching this video because you clicked on the link right here. And these are the things you're going to learn about: timed open, time close, on and off delay, relays, interval timing, written description of context, stuff like that. Okay, so let's start by our review from last week. So I just wanted to mention on the limit switches here that when you see a limit switch with a line like this, that means it's the same limit switch. Some of the normally open, some of the normally closed contacts. When you wire this up, all you do is you take a look at this one right here, and the gravity rule, because this is on the bottom, is it's a normally open contact. In this case, it's held closed, but because whether it's held closed or not makes no difference in how you wire it. All you do is identify that this is the normally open contact, and then find the normally open contact with your multimeter and continuity, and then wire it. This contact here is the normally closed contact, and once again, whether it's held open or not, it doesn't matter. All you need to do is find the normally closed contact and wire that one up, okay? And we talked about what would cause one solenoid to go off. One solenoid is right here. So the things that would cause this to not function correctly would be one of the fuses were blown throughout here. It's controlled by 1CR. So if for some reason 1CR becomes de-energized due to the logic here, it will go off. Or if you lose your control voltage here at your disconnect for whatever reason, that would bring 1CR down and one solenoid down. So those are the things that would turn 1CR off. The single coil circuit that's shown here, this is a little bit easier to connect because you have the spring returning the valve spool back to a normal position, okay? So the questions were pneumatic versus hydraulic, and as we mentioned, the arrows being dark here might indicate hydraulic, but the exhaust here, which it appears to be exhausting out into air, and you would exhaust air out here to infinite space, versus fluid you would want to put into a tank. You would want to spray hydraulic fluid all over the place. Single or double acting, that's a double acting cylinder. And once again, a short circuit is going to be a high current situation where you've shorted something. It's going to blow something fast. So maybe, I don't know how this control relay right here could get a short in it, or there'd be a dead short here somewhere where it would blow these fuses. Versus an overload, there's a high heat, that's a slower. And we talked about solenoids can overheat if they're cycling too fast, or if they can't complete their stroke, or if you're just trying to have them do too much work like that. And if that's the case, you would think that this 8FU would blow, okay? There was a solenoid and valve spool. You're going to really want to understand this for the quiz. And so this right here is shown by this pictorial here. And this has 1 square, 2 square. So this is a 2-position valve. And it's got A, B, P, T, 1, 2, 3, 4 ports. So this is a 4-2 valve. It's spring return, and it's solenoid activated. It's not air piloted. It's just straight solenoid, okay? And if you look up here, what this is saying in this normal position here, it looks like A allows flow to T. So if I look up here, you see that A flows through here to T, and it's blocked right there. And P goes to B. And so P looks like there's an opening around here to B. Now when this activates and this slides over here, you can see that P would be a straight shot to A. And if we slid this over, then this cavity would slide from P to A. And then you would see that P would be a straight shot to T. So if this slid over, it would be that would go to T. So that's how this is depicted here. So that was how you look at these ports, A, B, P, and T, and what the symbol looks like and how they work. You're going to want to understand those for the quiz. Lab answers. So the lab answers for the solenoid, there was a lot of questions there that you could answer just by looking at it and hooking up. If you want, I encourage you to stop and click here and go through and just check the lab answers versus yours. It's a little bit of a lengthy video, but you can take a look at the answers and see what you got right or wrong. Example cylinder logic. Let's just take a look at some more cylinder logic real quick. PB1 latches on the system and extends the cylinder. Cylinder 1 makes a limit switch which unlatches the system and causes the cylinder to retract. So this is using a single limit switch instead of 2 limit switches, and it's a little bit simpler than the one that we did, but hopefully you can understand this. So I encourage you to stop the video and watch the solution here. Today we're talking about timed relays. So this is a cutaway of a timed relay. So what a timed relay does, it's got a coil and makes a magnetic field, moves a plunger in there, and this relay is very similar to a normal relay where we have normally open and normally closed instantaneous contacts. That's just a relay. Up here we've just done, that's the same as a relay. You energize the relay and some contacts close and some contacts open, okay? But what the time relay has, it's got a second part on it down here, and this is for a pneumatic timer, there's bellows here. So these bellows let air through an adjustment here leak out easier or more quickly or more slowly, okay? So that's your time adjustment. So when you energize this time relay, these contacts down here try and close, but there's some pressure here or some in this bellow that prevents them from closing instantaneously. And it takes a while for this plunger to come up and reach the coil. If you want it to go faster, well then you open up the time adjustment here, you let more air leak in, and then it goes fast, or you tighten it and you let less air leak in and it goes slower. So these are time contacts. After you energize the coil, it takes a little while for these contacts to close or these contacts to open. So once again, these are instantaneous, just like a relay. Give it some juice and they change. These ones, if you give it the juice, it takes a little while for them to change. That's an on delay. So here's an on delay timer. And here's, I'm just going to make this as load 1 a motor and load 2 a red light. So the way that this one works is it looks like the red light is on because these are closed contacts, okay? And then when I hit the switch, it starts a timer, and after a couple of seconds, well, the motor goes on and the red light goes off. Maybe we could have a green light go on for the motor. But basically, that's the way that works. So when you think about, you know, timers and something like that, maybe you think about your garage door opener. When you push the button, or even in your car, the dome light in your car, maybe your garage door. The garage door opens, the light instantly comes on, you go in your house, and then after a couple of minutes, the light goes off. It's on a timer. It's same in your car. You shut the door, the light stays on maybe for a second or a couple seconds, and then it shuts off. It's on a timer. That's timing logic. So what I did is I went ahead and I wired up a timed relay, an on-delay timed relay with lights, and I posted the video right here. I highly recommend that you stop this video and take a look at this video here of that. Off delay. So an off delay is time relays, similar to a time relay in that it does have the instantaneous contacts up here, just like a normal relay, but these contacts work differently. For the on delay, once you energize the coil, these start timing. For an off delay, once you de-energize the coil, they stop timing. So back here, these are open or closed, depends on whether they're normally open or normally closed. You give the coil some juice, wait 2 seconds, they change states. On this one, you energize the coil, and these change states, but then nothing happens. Once you de-energize the coil, 1, 2, then they go back to their normal state. Okay, so this is hard for some students to understand. These contacts change back to their state after you de-energize the coil. Okay, and we're going to go all the way over it. So here is the off delay timer. Okay, so according to this is initiated right here. So this time relay is not timing. You have to de-energize the rung here in order for this to start timing. Going back to the on delay, this one's different. When you close the rung and energized it, that's when an on delay starts timing. Off delay, you have to make the rung false and then it times. Okay, so then what would happen here? If I made this false, this would be normally open timed open. So by closing this, I actually would cause this load to come on and this load to come off. I open this 2 seconds later. It returns as shown here, where I have this one off and this one on. So an off delay timer is going to be hard to get your head around a little bit. So what I've done is I've wired up an off delay timer with a couple of lights, and I am showing it here on the video. I highly recommend that you watch that. Time contact symbols for my on delay. So this one is a normally open time normally closed. So it's shown as an open, and the arrow says that it's going to close. And what happens? The contact is open. This is open. And when the relay coil is de-energized. When you energize the relay, nothing happens immediately. It's 1001, 1002, let's say it's 2 seconds, and then the arrow indicates that it's going to close. It's normally open, and it's going to time closed after a couple seconds. This is the normally closed time open. So this one's closed. It's shown as closed. The arrow says that it's going to open. All right. So when the relay is energized, there's a time delay, and then it opens. So these on delay ones seem to make a lot of sense, and we're gonna go over them. Well, these time contacts for the off delay are the ones that are a little bit confusing. This is shown as a normally open, okay? And the arrow says it's going to open. Okay, it's open and then it's going to open. That's weird. This one shows closed and the arrow says it's going to close. So once again, that's kind of weird that it's closed and then it's going to closed. Okay, so the way that these work is it's open. When I energize the coil, it closes. And it stays closed as long as that coil's energized. Then when I de-energize the coil, 1, 2, it reopens. It times open. This one here, well, it's showing as closed. Now we say it's going to time closed as well. So closed time closed. That must mean it's going to have to open sometime. So how do I open it? Energize the coil. It opens. After however long you want, doesn't matter. You de-energize the coil, and let's say it's 2 seconds, 1, 2, it'll close. Okay, so you want to really study these and take a look at those videos that I showed you to understand how these works. So when you're taking a look at these symbols and you're trying to figure out what they are, the way you do this is you start by take the symbol as it is drawn for the initial state. Okay, so I'm going to come in here. Excuse me. Ignore the arrow. The gravity rule right here says that this is open. So I'm going to make this a normally open. Okay? And then what? The arrow tells me the direction that it's going to go. Okay? So if it's open and the arrow's pushing up on this, that would close it, right? So the arrow is the timed, okay? And because it's open and the arrow's up, it's going to close, time closed. Normally open, time closed. This one, well, let's start with how it's drawn. Forget the arrow. It's drawn as a closed switch, right? So it's normally closed. Now let's get the timing on it. Well, the arrow says that it's gonna push on this, and it's going to open, right? So the arrow's indicating that this is going to open. So it's, oops, timed open. Getting it? Let's do another one. These are the off delay. They get a little bit harder. You start with the way that the switch is shown. The switch is open. so it's drawn as normally open. The arrow indicates which direction it's going to go. It is timed. The arrow's indicating that it's going to come down, which would be open, normally open, timed open. Just to remind you that if something is open and then it's after a while it's going to open again, that somewhere during the process it has to close. So that's what happens here. When you energize the coil, it closes. When you de-energize it, 1, 2, it opens. Doing another one. We have shown as a closed switch, and it's timed. Which way is it timed? The arrow is down. That's indicating the timing. The timing means that this is going to come down and make contact there, and it's going to close. Normally closed, timed closed. Remind you, if it's closed and it's going to become closed, somewhere in the process you have to open it, and that's what the coil would do. Okay. We have some time domains here that we're going to take a look at. So the time domains here, here's the normally open contact, the TON, I'm sorry, the on delay timer, and I also have the off delay timer on the worksheet. So I want you to go ahead and take a moment and watch the video here and determine how to do the time domains, and that's what that video link there is for. Okay, so that is a lot of information. This week's lab, you're really going to have to focus and understand how these are timing after either the coil is energized for the on delays, or how they're timing after the coil is de-energized for the off delays. And I'm telling you right now that typically the off delay timers are a little harder to wrap your head around, okay? And then also the symbols here, the way that we just went over, watch it again to figure out. You draw the symbol in its state, and the arrows indicate the end state, okay? And then finally, you're going to want to understand these two items here, the written description of how they time out. So at this point, watch all the extra videos, fill out your lecture worksheet, and turn it in.